Okay, in this problem we're going to review how we find the angle of depression or do an angle of depression problem. It says the angle of depression from the top of a building to a point 85 meters from the foot of a building is 64 degrees. It says find the nearest meter the height of the building. So again, with these problems we want to make sure that we draw a good picture. So let's go ahead and go to our picture. We've got a building. Again, it doesn't have to be a masterful piece of artwork. It says the angle of depression from the top of a building to a point 85 meters from the foot. So there's a point that is 85 meters from the foot of the building. It's telling us the angle of depression is 64 degrees. So as I draw in my line, okay, we're saying that the angle of depression, now it's important, angle of depression goes from the horizontal down to the point. So it's common to put the 64 here, but that's going to get your answer incorrect. The angle of depression goes right here. So it's 64 degrees. Now, the 64 degrees, because we've learned about parallel lines, this horizontal and the ground are parallel, so these two angles here are what we call alternate interior angles, and we know that because the lines are parallel, those have to be the same. So I'm also going to put my 64 degree angle right down here in the triangle. What that allows me to do is, remember, if we go back to our problem here, the question is asking us find the nearest meter the height of the building. Well, in my picture, here's my building, here's the height. So similar to our angle of elevation problem, we have the opposite side, that's the height of the building, and the adjacent side to this angle. So we're going to utilize in this problem, again, the tangent, that's TOA. Tangent of 64 is equal to the opposite, which is x, over the adjacent, which is the 85. And again, from here it becomes a calculator problem. I'm going to type into my calculator tangent of 64, hit enter. It gives me 2.05. I'm going to multiply that number by 85 to solve my equation, and that gets me 174.2. Again, we're rounding to the nearest tenth, so we would say here the height of the building is 174.2 meters.